Welcome to RGES Algebra 1. This is Lesson 8B. We're dealing with solving literal equations and plugging in or substituting to work with formulas. So our first example would be this. By the way, literal equations comes from the idea of literary or litera, meaning letters. So we're looking for equations with more than one variable where you want to solve for just one variable. So here's our first example. 5y plus 3c equals 17, and we want to solve it for y in terms of c. That means we want to treat the c just as though it were a number and it wants to go, or a constant, and it wants to go to the other side of the equation. We're trying to solve for the y. So we would take their 3c over in the normal way by subtracting, and we would get 17 minus 3c, and now we would have to divide by 5 so that we get y by itself, and that's what you end up with. So notice you will have variables on the right side of the equation. Let's do another one here. If we wanted to solve A equals LW, but this time I want to solve for L. So I'm going to treat L as my variable. So in this case, because I like my variables on the left, I'm going to just rewrite this with the right side of the equation on the left and the left side of the equation on the right. I'm solving for this, so I would need to divide both sides by W. Just like that. And so don't let it scare you when you have more than one variable. In fact, in algebra, this tends to be the pattern. So let's look at the next example on page 146. This is merely an example of how to use a formula. It says the length, L, of a rectangle is given in terms of the area and the width. So if you want to find the length, you're going to take the area and divide by the width. And we want to know what is the length if the area is 300 and the width is 8. So I'm just going to substitute for the area 300 square inches, and I'm going to substitute for the W, or the width, 8 inches. Notice this is square inches and this is inches. Okay, so I'm going to show you something about units too. So I'll simply take 300 divided by 8, which is going to be 37.5. And notice I have inch square, or inch times inch, in the numerator and inch in the denominator. So that will leave me with, I should say inch times inch, sorry. Okay, and that cross one of those inches out, and that'll leave me with 37 inches as my length, which is what you would expect, a linear measurement of inches. So that in truth actually works out even with the mathematics. And so the next one would be if A is 0.4 square miles, so we would have 0.4 square miles, and W is 0.025 miles. And so again, that actually should say 0.025 for the width. It should not say square miles in his example. In the text, it really should just be miles. And so our length is going to be doing the arithmetic for that, and that would be 16 miles. So these are just really substitutions. The only trick to using a formula is making sure you understand what everything stands for. Let's look at the last example. This is a very, very common formula. This is rate. Rate equals distance over time. Think of the rate of driving the car as miles. That would be a distance, right? Oh, miles per hour. That would be an example of the time. So miles per hour is an example of rate. It says write a formula for R in terms of D and T. So we're going to first solve it. Well, actually, that's what I just did. Sorry. And so B says solve for D in terms. So I want to solve for D. And again, I like to rewrite it, the right side on the left. You don't have to do this, just look at a verbal, just mentally, but I like to illustrate it this way. So I'm going to multiply by T, and D equals rate times time. Okay. And notice I don't need the multiplier sign in there because two variables next to each other means multiply. Okay, and so then to evaluate D when the speed is 55 miles per hour, and so I want to know what the time, or what the distance is when the speed is 55 miles per hour, so I'm going to substitute 55 miles per hour. And for time, I'm going to substitute 4.2 hours. And I am multiplying these, okay? And so miles per hour simply means miles over hour, right? Per hour. And so if I take 55 times 4.2, my answer will be 231, just because I know what I'm dealing with. My unit is going to be miles. Whoops, it looks like I wasn't taping. I don't know for how long. So let's go back and talk about this for a minute. Here is our formula, as we talked about. Notice rate equals distance over time, and when we think of the car speed, miles per hour, that would be the distance, and this would be the time. So that's a very common one for us to think of in terms of rate. When I solve for D, I'm going to take the right side of the equation to the left and the left side of the equation to the right, so that the variable I want to solve for is on the left side. So I'll multiply by T, and I get D equals RT. And then for the next part of the problem, I'm going to substitute 4.2 hours for my time and 55 miles per hour for my rate. If I'm multiplying that out, I get 231. And notice miles per hour is the same as miles over hours, and times hours. So my hours will cancel, and I'm left with miles, which I knew in this particular example, but I want to illustrate the fact that units actually follow through mathematically. Now, if you will grab your book and go to page 147, put it on pause, and I want to illustrate a little bit about this. Okay, so it says evaluate the formula for the given value of the literal constant. This is put in a little bit funny form, but notice on the left side it says x equals 9g. So as you're working for A, B, and C, you're using that equation. So if g equals 5, you plug in the 5 here for A, and you get 5 times 9 or 45. If g equals 200, you're plugging in here, and you're getting 200 times 9 or 1800. And that's what they're trying to do. So do the rest on your own. D, E, and F would relate to the equation y equals 7p, etc. Now when we get down to J, solving the literal equation for x, it says 5x equals k. So to solve for x, I'm going to divide by 5, k. To solve for x, I'll divide by c, L. To solve for x, I'll divide by f. M, to solve for x, I'll subtract e. N, to solve for x, I'll add 7. O, to solve for x, I'll subtract w. P, to solve for x, I'll multiply by 3. And Q, to solve for x, this is a little trickier. Let's do Q. Okay. U over x equals 5. This really, to explain this carefully, I'd probably look at this as a two-step problem. I would look at this by multiplying by x, I would end up with U equals 5x. Now I'm solving for x, so now I would divide. So I would say x equals u over 5. There are a couple different ways you could look at that. All right, but that's certainly a good one. Okay, so Q's a little bit trickier. All right, so do the rest of these on your own. Be careful that you want to simplify every problem, and you want to do order of operations. So be careful for both those things. Try to do both your word problems, and then come to class. I'm going to write the answers for 32. I'm also going to do one other thing here. Looking at number 3, I need to solve for x, so I'm going to go negative 2x, subtracting the 4 to the other side. And then I'm going to divide by negative 2, and I'm going to get x equals, I'm sorry, that should be a g. G minus 4 divided by negative 2. Now watch this. That's not a good form. I'll want to take that negative out of my denominator, so I will end up with negative g, distributing my negative sign through my terms in the numerator, negative g plus 4 divided by 2. Okay, so they give you the answer as 4 minus g divided by 2, and that means the same thing. So just be careful with things like that. All right, for number 32, you're asked to do this word problem, and I'm just going to give you the answers here, and you come in if you can't figure out these answers on your own and ask. This one would be 36 pounds per square inch. B would be 2304 pounds per square inch, an amazing answer as you read it in context, and 3 would be 300 pounds. So if you're not getting those answers, be sure to come in and ask. The rest of the answers are in the book. Your word problems on 4.6 are all in your book, and I would like to give you the answers to your word problems on 2.8. So here are your answers for 2.8, number 2 through 8. Check these very carefully. I'll put the last two on the last 3 on the next page, but I will be considering these fair game to ask you questions like this. So make sure you're understanding these very carefully. Okay, this wraps up the answers for the word problems. Be very, very careful with your working of the word problems. This is one way that this particular textbook excels, is stepping you through those word problems so they start making a lot more sense to you. So I highly recommend that you take your time with these. And like I say, you will be tested on them. So if you have any questions, make sure you bring them to class. Okay, have a good vacation. We'll see you when you get back.